Sue believes that the two cylinders as shown in the diagram below have equal volumes. Is she correct? Explain why. So looking at this right now, the two cylinders, one is a right cylinder and the other is an oblique cylinder. Oblique meaning the altitude and the lateral edge are actually not aligned. Okay, so so this question is really asking whether or not you are familiar with Cavallari's principle. I hope I'm spelling his name correctly. Cavallari's principle. And what that really says is if you have any shape, and it doesn't matter whether it's a cylinder or not, it could be of a cone, it could be of a pyramid, it could be of anything. Okay, if you have one figure that is a right, meaning like the altitude is going to be perpendicular to the base, and that altitude runs through the middle of that object, versus another object where the altitude is not in the object itself, where it's oblique. Cavallari's principle says that these two are going to have the same exact volume. Okay, so Cavallari's principle, these two are going to have equal volumes. So both volumes will be equal. Because altitude and radius are equal in both figures. So because of this, right, you can actually, figure out what the volume is. The volume of the one on the left is equal to pi times 5 squared times 11.5. And the volume on the right, okay, is the same thing. They're given the diameter, which is 10. So the area of the base is, again, 5 squared, and then times the altitude is 11.5. This Cavallari's principle, even though it's given a fancy name, it's really, really analogous to this situation. Let's say if I have two triangles. Let's say I call this B, right? And I call the altitude of this H versus, so that's a scalene triangle versus an obtuse triangle, right? Where it has the same length base, but the altitude is outside of the triangle here, okay? And this is H. The base only covers what the actual length of the triangle is, right? And the height here is the physical length of that vertex, what that distance is of that vertex to the base, if we were to extend that base. So you can see here, both of these actually have the same thing. It's the area is, again, 1/2 base times height for both of them. Okay, so the Cavallari's principle, it really is an extension of our understanding of finding the areas of a triangle between a scalene versus one that's obtuse. They will end up having the same as long as the dimensions are the same, as long as the vital dimensions regarding like altitude and the base, okay, as long as they all remain the same.